There we go. Oh, good. Okay, let's take a look here. Whee! One of the hardest things to remember is when do I multiply, when do I add, and when do I, what have you. When you multiply like bases, that's when you add. You're just consolidating the number of whatevers. So I have m squared so far. Somebody put 7m's next to that, so of course I have 9. Careful. Well, how would I make it 14? It have to be m squared to the 7th power, right? That would be 7 groups of 2m's. That would be 14m's. This is 2m's next to 7m's is 9m's in a string, right? What does m squared look like? M times n. What's m7 look like? M times n. So how many would there be total in the string? 9 of them. Okay. But your brain is still going to do the wrong thing at the wrong time if you're not like on top of it. Brain, stop it. What about, and so this guy's going to be what?
28.
Yeah, a to the 20th. And now this guy, order operations saves your ass. It'll work even if you bring a 3 in first, but I always tell people you should simplify inside first. It's just be 2q to the 8th. What's being cubed? Everything. So 2 cubed is 8. And then what do I do with these?
24.
Multiply. I like it, just like we did here. That's the same thing as that. Bam. So this guy, is there any foiling I'm going to do here?
Yes.
No. Why not? How many terms are here? 1. How many terms is this? 1. What would foiling take? Foiling would take to a 2-term thing times another 2-term thing, right? Then I would FOIL. Technically, we haven't learned FOIL yet, to be honest, but we all know FOIL. So here, if I have 3x times 2x, what is that? 6? X squared. You multiply 3 times 2 because you can. And you multiply x times x because you can. And what's 6 times x squared? 6 times x squared there. It still is multiplying these two. I just can't rewrite that. I don't know what 6 times x squared is. I can't push them together more. So here, what am I able to multiply? 3 times 5 is 15. So there's my numbers taken care of. Now move to the b's. b4 times b squared. b to the 6th. 1d times 5d's. d to the 6th. Bam. There's no foiling. I always have people somehow, they foil this out. There's no plus or minus in there. It's just 1 term times 1 term. So the answer should be 1 term. All right. Bless you. Bless you. Here's our first little foray with negative powers. Wherever the hell it is, it wants to be on the other side. So these 3 x's are up top. They want to be down here. 4 over 18 is 2 over 9. X 4 times x cubed. So if you actually rewrite it with positive powers by moving them, you get a much easier problem to look at. You can take the negatives out of it. Now here, this is just straight up, this is like this problem just with one more thing sitting next to it.
Can you go back to you?
Oh yeah. So those 3 x's go down. There are 4 there already, so now there's 7 on the bottom. And the numbers, 4 over 18, acts the same way it always did. Is that all right? I suddenly have people that think, for example, I have a problem with a 2 over 5 in it somewhere, and somebody tells me that equals -3 or something. Why 2 minus 5? You see that?
Yeah.
But you would only subtract if they were actually powers. What's a squared divided by a to the 5th? So why do these act differently? They don't. They do not act differently. Is there a 2 in here somewhere? No, there is no 2. There's no 5. There are 2 a's and 5 a's. Here, is there a 2 in this? Yeah. So of course it's going to act differently than this. This doesn't have a 2. This does. Maybe. So here, treat that like its own problem. What do I do to each thing inside? It's crazy. So it's -2 squared. 4. X to the 6. Y to the 10. Z to the 4th. And next to that, I'm going to write this guy. What's -3? And why am I doing this? Do I multiply or raise to a power? Which one do I do first? Exponents or multiplication? Exponents. Order operation saves your ass. -3 cubed. -27. Not 9, that would be squared. -27. X to the 6. Y to the 12th. Z to the 3rd. And now it's just like this problem was. Just with kind of bigger numbers. 4 times -27 comes out to be 108. How many x's total? 12. How many y's? 22. How many z's? 7. Shabbat. So exponents really are just a way to consolidate how many whats am I multiplying. That's why the properties are the way they are. What time we got? Let's do this one. Well, let's do these 2, and then we'll head out. We'll do the rest of them next time. The numbers, just do them. That problem is the same as always. 12 over 15. What do I do with that?
4/5.
Yeah. Don't suddenly make those become different. They can't ever be different. We already established what they do. What happens here? Yeah, those 4 a's go down. So how many a's now? 6. There were 2 there already. 4 more coming. What else moves?
The B's go up.
Yeah, those 3 b's go up. There were 2 there already, so now there's 5. What else moves? Those 3 c's go down. There were 3 already, so now there's 6. Done. Yes? Oh, H. Here we go. You ready?
Yeah, H is
Anything to the 0 power is
1.
1. What's being raised to the 0 power here? The x. So the 4 stays the same. 4 times, what's x to the 0? 1. So it's 1 minus 4 times 1. Why the hell would 4 change? It's not being raised to a 0 power. So this is 1 minus 4. -3. Pew! Alright. So we'll do the other 2 next time. That's plenty for today.